Hi everyone, welcome back to my channel. Today we are talking about chemical kinetics. Kinetics is a branch of chemistry that deals with three main topics, that is the rate of the reaction, and the second one is about the factors that affects the rate of reaction, and the third one is about the mechanism of the reaction. Done? You can also take the notes. You can pause the video and take the notes. The most important basic topic is the chemical reaction. What is chemical reaction? It's nothing but the one or more substances when reacts to give product. Then next comes on the basis of this rate of the reaction or the speed of the reaction. Chemical reaction can be defined in three types, three major categories. The very fast reactions. In this type of reaction, time taken is in the range of 10 to the power minus 16 to 10 to the power minus 12 seconds. These are very fast reactions. For example of these reactions like HCl plus NaOH, which gives the output of NaCl plus H2. As this is a very fast reaction, there is no bond formation because it takes a long time. So no covalent bond formation. And here elements or the reactants reacts in ionic form. Okay, so now these reactions can again be written in the ionic state, which actually takes place. Then in ionic state, that is H plus Cl minus plus Na plus OH minus, which gives the output of Na plus Cl minus plus H2. Done. Now we are talking about chemical kinetics, that is determining and just describing about the rates of the reaction. As this is a very fast reaction, so rate of this reaction can't be determined. So we are not talking about these reactions in further chapters, like for the numericals or just getting an example and describing this topic. We not consider these reactions, this type of reactions. Done. Now there comes the other types of the reactions, that is very slow reactions. This is also like example rusting. This takes a whole lot of time, so we are still not, rate is not determined, or it can't be determined. So again, we are not talking about this type of reactions in the whole remaining chapters. Okay, now the third type of this reaction, that is the moderate speed reaction. This is our main topic of interest. Okay, so moderate speed reactions. Done. पॉइंट ये है कि यही पढ़ना है आगे जाके. Example like decomposition of H2O2. इक्वेशन क्या रहेगा कि H2O2 डिकम्पोज करने से H2O प्लस O2 फॉर्म हो रहा है. balancing. Right now balance the equation and it comes actually 2 and then right. Chalo. Now we can determine the rate of this reaction. We can determine the rate of the reactions. Again, chemical reaction can be categorized into two parts based on the steps of the reactions. Okay. Chemical reaction can be categorized into two parts. The first one being the elementary reaction. This is a one-step process. Done. Second one is complex reaction. This is multi-step process. Okay. So actually we'll talk about this type of reactions because it has a determining step, that is the slow step and the fast step, which actually determine the rate of the reactions. Okay. Done. And a basic overview of this type of reaction, it can be said that if the reactant is, suppose let us consider this is R and product, considering it P, so the basic reaction flows, it's like R to an intermediate product R1. Now again R1 reacts to give a product like R2. Now R2 when it reacts gives this product P. Ultimately when it will sum up, when we sum up, then all get cancels out and ultimately the product is R2P. Got it? The reaction flows in this way. A practical example of these reactions like when HBr plus O2, it turns out H2O plus Br2. Now doing the balancing, this one, then, and the reaction is a multi-step reaction, the complex reaction, and it proceeds in a manner like first HBr plus O2. This is slow, gives the product of this, saying like R1, another intermediate product. Then again this react, which gives again saying this is R2. This is also fast. We cannot determine the rate through the first reactions, though we have to determine the determining step is the slow part of the reactions, and which gives the ultimate product of H2O plus Br2. Then when we sum up this, it gives product like HBr plus O2 is H2O plus Br2. Got it? We'll talk about more about these complex reactions which are multi-step reaction. What is rate of reaction? We're talking about this rate of reaction from the time being, that what is the definition of the rate of reaction? It can be defined as the change in the concentration of the reactants and products, that is the change in the concentration of the elements that are participating in the reaction. Done. And initially we actually consider that the rate of the concentration of reactant is 0, of product is 0, because after the reaction the product will form, right? And the concentration of reactant gradually decreases. In other term, it can be defined as rate of reaction is decrease in concentration of reactants along with the increase in concentration of product. As the reaction proceeds, the reactants quantity will decrease and the product quantity will increase. Okay. Hypothetical reaction, that is wait, let me write. Reaction where Na reacts to produce Mb. This is what? N molecules of A reacts to produce M molecules of B. Suppose considering time t1. Okay, after the initial point, then comes time t1, where the reactant concentration decreases to A1 and the product concentration increases to B1. As we have seen, with increasing the time and the proceeding of the reaction, reactants amount decreases. Now again time t2, considering t2 is greater than t1, the reactant amount decreases to A2 and the product amount increases to B2. This is actually for moderate type reaction. Okay, now the concentration of A change in concentration of A can be written as A2 minus A1. This whole term would be negative because we know that with the increase in time the reactant's concentration will decrease, so this value is smaller than this, therefore it gives a negative term. Okay, again change in concentration of P can be written as B2 minus B1. This term will be positive because product concentration will increase with the increase in time. Okay, now the time interval is t2 minus t1, a small time interval, that is why we can write delta t. Okay, now there comes the point is with the increase in the time the reactant will disappear. If we write the rate of disappearance of A, this is change, the formula this can be written as the change in concentration of A by the time interval, which is nothing but A2 minus A1 by delta t whole. This will be negative term because this is negative. Okay, now with the increase in the passage of the time, the rate of appearance, not this is can be written as rate of formation of B. This is B2 minus B1 by delta t. Okay, this is actually a positive term. Short, we can write it as delta B by delta t. Again, this can be written as minus of delta E by delta t, delta for small difference. Okay, now we can say that rate of reaction, in the definition we have seen that rate of disappearance of reactant and rate of production or the formation of A. So this is equal to rate of disappearance of A, which is again equal to rate of formation of B. So the formula, a general term, can be written as R, being the rate of reaction, is minus delta A by delta T, which is equal to rate of formation of product. Practical example, suppose A plus B, being the reactant, reacts to produce C plus D. For this reaction, rate of reaction R is delta A by delta T, again which is equal to minus of delta B by delta T, which is again equal to delta C by delta T, and delta concentration of D by delta T. Okay, see that the type of reaction where there is no stoichiometric coefficient, that is, there is no extra molecules of reactants, so the products are required, then that this type of reaction do not have any stoichiometric coefficients. Now the rate of the reaction is definitely going to change when there is a stoichiometric coefficient in the reaction. Considering the reaction like A plus suppose 3B, which gives the output as 2C. Now when I write this equation, this shows that one molecule, 1 mole of A reacts with 3 mole of B, gives 2 times of C. Okay, now again we have seen that all these terms are same. All these terms are same, like concentration, change in the concentration of A along with the time, and the change in the concentration of B, both are equal. Okay, now in this reaction, when I will write the change, in concentration of A is not equal to only the change in concentration of B, because there is a coefficient now. So in this case we have to see in this manner that 3 into rate of disappearance, rate of change in B is equal to 1 times rate of change in A. Again, in terms of relation between A and C, the relation will be 1 time rate of appearance, oh sorry, not this one, rate of change in B is equal to 3 times the rate of change in A. Okay, again, so 1 times the rate of change appearance of A is equal to 2 times of C, is equal to 2 times of A. Okay, so this is A in terms of C, right? That rate of reaction in terms of, it can be minus delta A by delta T. Again, it is minus delta B by delta T, which is 3 times of minus delta A by delta T. Got this point now from this one? Again, rate of reaction in terms of C, it can be written as delta C by delta T, which is again equal to 2 times of delta A by delta T from this line. Okay, so for the whole reaction A plus 3B to 2C, from whole this reaction we can write the rate as minus delta A by delta T, again which is equal to minus 1 by 3 of delta B by delta T, which is again equal to 1 by 2 of delta C by delta T. So yeah, this is actually the general term in determining the rate of this reaction. So again, in any of the examples where there is an coefficient, like you have a stoichiometric coefficient written in the reaction, then the formula will be this. So the general formula, this is R is equal to minus 1 by V suffix R delta R by delta T, 1 by V suffix P delta P by delta T, where R and P both are the obvious part, reactant, and P being the product. Okay, and V suffix R and V suffix P is the coefficient of R and P, of reactant and product. Okay, got it. Now taking a practical example, like 2N2O5, which gives 4NO2 plus O2. What will be the rate of the reaction? Okay, perfect. This is 1 by 2 minus delta of N2O5 by delta times T, which is 1 by 4 of delta change in the concentration of NO2 . Okay, that's it.